So question number 18. We have x to power 4 minus 3x to power 3 minus 15x squared plus 24x plus 58. And we need to find that based on this polynomial function, if there is real zero between -3 and 2, -2. Okay, so what do we need to do? We're plugging f of -3, and then we will plug f of -2. So -3, it's going to be -3 to power 4 minus 3 times -3 to power 3 minus 15 times -3 to power 2 plus 24 times -3 plus 58. Okay. -3 to power 4, it's going to be 81, positive 81. Now -3 to power 3 is going to be -27, and times 3, I'm solving this one. So times 3, it's going to be 7 times 3, 21, 2, 6 and 2, 8. So it's going to be positive 81, because this -3 to power 3 is -27, and 3 is also negative, so together will be positive 81. And then -3 squared is positive 9. 15 times 9, it's going to be 45. 9 and 4, 13, and it's going to be negative 135. And then minus 12, 6, 72, and plus 58. So this is going to be equal, let me see, it's going to be equal 13. Okay. F of -2, it's going to be -2 to power 4 minus 3 times -2 to power 3 minus 15 -2 to power 2 plus 24 times -2 plus 58. And if you do this math, because I already did, to save time, it's going to be -10. So what did we get? We get 1 is positive, 1 is negative. That's mean since the y values of y's, which is f of -3 and -2, they have opposite sign, positive and negative. That means there is a zero of the polynomial between -3, -3 and -2 points. Question number 19. Question number 19. Let's see what we have. Given polynomial graph, we need to write down the function. So this is what we have. -4. This is 0, 70. This is 5. And this is 7. So the graph is coming like that. That's it. Okay, so how we gonna work? First of all, let's identify intercept. X-intercept, it's negative 4 and 0, 5 and 0, and 7, 0, right? These points, 1, 2, 3. Y-intercept is 0, 70. Okay, so to restore the equation, when we use x-intercept, we are going to flip on opposite sign, right? If it's negative 4, it's going to be x plus 4. If we have positive 5, it's going to be x minus 5. And if we have plus 7, we will be x minus 7. Okay. Now we need to find out if there is any coefficient. How are we going to find coefficient? Via this y-intercept. So where we know when x is 0, y is 70. So let me plug 70 and 8 times. So 0 plus 4, 0 minus 5, 0 minus 7. Yes, we get 70 is equal. What do we have? 4 times negative 5, it's going to be negative 20. Negative 20 times negative 7 is going to be negative 20, negative 7, it's going to be 140. 140 A. Yes? So we need A. What we do? We divide by 140 here. We divide by 140 here. This is gone. Here will be 1 and 2, which means A is equal 1 over 2. So from here, the final form of polynomial based on this graph, we get f of x is equal 1/2 x plus 4, x minus 5, x minus 7. Okay? And we have the last question to cover, question number 20. It's the same way. So, in x-intercepts, we have negative 5 and we have 3. Y-intercept is 0, 9. So the graph is coming like this. Okay? All right, so let's write down our intercepts. So x-intercept, what do we have? Negative 5, 0 and 3, 0. Y-intercept, it's going to be 0 and 9. Okay, let's see. Remember, we are going to flip the sign for x-intercept. So if it's negative 5, it's going to be x plus 5. And it's going to be x minus 3y. Because if you assign it's equal 0, x plus 5 is equal 0, then x will be negative 5, which will get original here value negative 5. Okay? All right. So now let's figure out if we have any coefficient here. What we're going to do, use this y-intercept. Which means the y, which is 9, is equal a times, okay, and x is 0, plugging 0 plus 5, and 0 minus 3, and we get 9 is equal, 5 times negative 3 is negative 15a. So to get a, we divide by negative 15, yes, and we divide by negative 15 here also. Let me check one more time the coordinate if I put it correct. Negative 5, 0, 9, and 3. Okay. Here is interesting thing, and let me tell you. So at the point of 3, we have it's curving, right? When it's curving, that means multiplicity is going to be even. Remember, when the multiplicity is odd, then it's crossing, right? This way or this way. But if it's multiplicity even, it's going either this way or this way. Now, since it's curving here, turning around, then at the point 3, it's going to be at least squared. Okay. Which means if it's going to be squared, then instead of 15, we're going to get some different numbers. Let's see. Negative 3 squared of this negative 3 squared will be 9, and 9 times 5 is going to be 45. Positive 45. Okay. Which means we are going to divide by 45. So this is gone, here is 1, here is 5. And we get a is equal 1/5. So which means the full form of the polynomial is going to be 1/5 x plus 5 and x minus 3 squared. Okay, I'm done. I wish you good luck on your group activity and test, and I'll see you in next homework. Bye.